Nagoya, Japan, early 1990s. Lunch break at Denso, the auto parts giant that keeps Toyota's assembly lines fed. At one of the tables, an engineer named Masahiro Hara isn't eating. He's staring at a go board. Black stones, white stones, packed into a grid, 19 lines by 19 lines, no wasted space, readable from any side of the table. Hara wasn't in R&D to think about board games. He'd been handed a much less romantic problem. The auto parts scanners his team built were choking. And staring at that grid, something clicked. Not, "Here's my answer," but "Here's the right kind of question." What if the code itself was a grid? Not a strip, not a line, a field. That single mental shift is the entire origin of the QR code. But here's the part almost nobody tells you. Knowing you want a grid doesn't tell you what shape that grid should be. And the shape turned out to be the hardest part of the whole project. Rewind slightly. It's 1992 and Denso's factory floor has a data problem. Barcodes, the classic black and white stripes, can only hold about 20 characters. A single car part might need more information than that. Part number, batch, supplier, revision. So workers were slapping 5, 6, sometimes 10 barcodes onto one component and scanning them one at a time in order by hand. Denso Wave's own account puts the toll at roughly 1,000 scans a day per worker, repetitive, slow, and one misread barcode from grinding the line to a halt. Hara's assignment wasn't glamorous, build a better barcode reader, but he became convinced the bottleneck wasn't the reader, it was the shape of the data. A barcode only encodes information in one direction, horizontally. All that vertical space above and below the stripes? Wasted. Dead real estate. So the real brief, once Hara reframed it, was this. Design a code that uses both dimensions, something that could hold 200 times more data in roughly the same footprint, and, this part mattered just as much, get scanned in a fraction of a second, because factories don't pause for careful aiming. That's a grid problem, and once you're solving a grid problem, you have to pick a tile. Denso's team didn't just default to the square. They ran into a wall with almost everything else first. Let's put ourselves in that lab and audition the obvious candidates, the way an engineer actually would. Not which shape looks efficient, but which shape survives contact with a cheap camera, a smudged label, and a worker holding the scanner at a weird angle. Candidate 1, the circle. Circles seem elegant. No wasted corners, perfectly efficient use of area for a single dot. But circles have a fatal flaw for this job. A circle looks identical no matter how you rotate it. That's a disaster if your scanner needs to know which way the code is facing. A barcode reader has to figure out instantly, is this thing upside down, sideways, mirrored? A circular marker gives the scanner zero information to answer that question. It's rotationally symmetric, which sounds like a virtue and is actually the opposite. You need asymmetry to detect orientation, and a circle refuses to give you any. The hexagon. Hexagons tile a plane perfectly. Ask any beehive. But a beehive isn't being photographed by a rectangular sensor made of a rectangular grid of pixels. Every practical imaging sensor, then and now, is built from a rectangular array of squarish light-sensing elements arranged in rows and columns. Try to map a hexagonal code onto that pixel grid, print it with an inkjet or laser printer that also thinks in rows and columns, and you introduce a mismatch at every single edge, rounding errors that compound as the code gets denser. The hexagon isn't wrong geometrically, it's wrong for the machines that have to read and print it, which are square native from the sensor up. Candidate 3, the triangle. Triangles tile too, and they're cheap on data density, since 3 points define very little area for their perimeter. Worse, for finder-style markers, a triangle rotated by 120 degrees looks almost the same as it did before, enough ambiguity to trip up fast, low-resolution scanning under factory lighting, exactly the conditions Denso needed to work in. 3 shapes, 3 specific failure modes, no rotational information, no compatibility with the pixel grid, not enough usable orientation cues. Notice none of these are, and also it looked bad. Each one broke a concrete engineering requirement. A caveat for the record, the historical sources document that Denso's team spent roughly 3 months testing which specific black and white pattern would be recognizable and rare enough for a scanner to lock onto. This shape elimination logic reflects the actual physical and optical constraints they were solving for, even if the surviving public accounts don't itemize every alternative geometry they sketched on a whiteboard. So what's left standing? The square, and it wins for reasons that go deeper than it's simple. First, cameras and printers are both built on rectangular grids. A square module lines up with a square pixel, which lines up with a square dot of ink, with no rotational rounding error at any stage. The whole imaging pipeline from lens to sensor to printer head is fundamentally rectilinear. A square code isn't imposing itself on that pipeline, it's speaking its native language. Second, and this is the real masterstroke, Hara's team needed the scanner to instantly answer which way is up, without the code carrying any extra label. Their solution was the 3 big square eyes you see in every QR code, tucked into the top left, top right, and bottom left corners, with the 4th corner left conspicuously, deliberately empty. That absence is the trick. 3 identical markers plus 1 missing corner is an asymmetric shape, even though every individual piece is symmetric. The scanner just has to find those 3 distinctive squares, a black ring, then a white ring, then a solid black center in a 1:1 to 3:1 ratio the team confirmed was almost never found by accident in ordinary printed material, and the moment it locates all 3, it knows exactly which corner is missing, and therefore exactly how the whole code is rotated. No 4th marker needed. No compass, just geometry doing the work that used to require careful human alignment. The square didn't win the audition because it was first. It won because it was the last shape that satisfied every constraint at once, printable without distortion, photographable without loss, and with just 3 copies of itself and 1 calculated absence, self-orienting. Here's the part that reframes everything. That square grid logic isn't a quirk Denso invented for QR codes, it's the shape computers already thought in, and QR codes just borrowed it. Your camera sensor is a square pixel grid. Your screen is a square pixel grid. The chips inside both are etched using square-based lithography, because square tiles are what fabrication equipment can align with sub-micron precision, generation after generation. A JPEG compresses your photo by chopping it into 8x8 squares. A QR code is, in a very real sense, just another image file that happens to be designed for a human to also point a phone at. Hara wasn't imposing a foreign shape onto machine vision. He was matching his code to a geometry computers were already speaking fluently, decades before smartphones made that compatibility obvious to the rest of us. So, next time you scan a QR code to pull up a menu, you're not looking at an arbitrary design choice. You're looking at the one shape that beat a circle, a hexagon, and a triangle in a contest none of them knew they were entered in. A contest that, as far as we can tell, started with one engineer staring past his lunch tray at a Go board, quietly relearning how to see a grid.